Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1695, maximum erasure value. In this problem description, we're told that we're given an array of positive integers called nums, and we want to erase a subarray containing unique elements. And the score we get by erasing this subarray is equal to the sum of its elements. And we're told that finally we want to return the maximum score we can get by erasing exactly one subarray. So we want to find basically a subarray which has only unique element, the largest subarray with unique elements, and we want to erase that subarray from the array of positive integers called nums. And the biggest score we can get is the size basically of the biggest subarray with unique elements. So subtracting that will give us a score, and we know that the score is going to be not the size of how many elements are in this subarray, but the sum of all the elements in the subarray. So we're given two examples over here, and in both examples you can see we are shown what the optimal subarrays are, and those optimal subarrays are basically the largest subarrays you can get without any duplicates. That in the subarray, the largest subarrays you can get without any duplicates, that's going to be the result, or the result of the sum of that subarray is going to be what we return. So it's quite a simple problem, and you might have guessed by now that this is a sliding window problem. We want to have a window and we want to pop elements from our window if we encounter duplicate. Otherwise, we want to just carry on increasing our window size and comparing it to previous windows. So let's actually get writing some code. So first thing we want to do is create a scene set. And this is going to say if we've already found an element like you, we've already seen you before, we want to now shrink our window until we no longer have any duplicates. We want to have a result. We want to have our left pointer because we are using a slider window technique, and we want to have a current sum. And we're going to say while r in range, or for r in range, length of nums. What we want to do is first say, let's say if nums r is in scene, well then we want to remove you, we want to shrink our window. So we want to say let's l plus equals 1, but also that should actually be equal to 0 initially. We want to say current sum should be minus equals nums r. And then what we want to do is also remove from our scene set this number, scene dot remove nums r. Okay. So once we've shrunk the window, we've removed all duplicates if need be, we can say scene dot add nums r, and we can increase our current sum. So we can say current sum plus equals nums r. And then we can set our result. So our result is going to be the result that we return, of course, and that's going to be equal to the maximum of what we already have compared to the sum, so basically compared to the current sum. And then once we've finished from our for loop, we can simply return our result. Now let's run our code and check that it passes all test cases, and we get the wrong answer. Why do we get the wrong answer? Let's actually look through the code. Okay. Okay, so we want to remove nums L. Okay, so we don't want to remove nums R. We don't want to remove elements from the right hand side because we're not shrinking from the right hand side. We want to shrink from the left hand side, so we want to remove the element at the pointer L. And now we can see our code works and it passes all 62 test cases. So in terms of time complexity, for this problem, guys, we're looking at a big O of n for time. And we're also looking at a big O of n for space. So both for time and space, because worst case scenario, we could have all the elements in our set. So big O of n for both time and space complexity. And with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.